Hello everyone, this is Suresh Sukarma presenting Divine Public School in the e-learning classes. Today we are going to learn, the subject is Mathematics, class 10th, chapter 2, part number 4, and you know that your chapter is Polynomials. Presenting Suresh Sukarma. In this module, we are going to learn the explanation about the sum of the exercise 2.2. So, the exercise 2.2 we are going to start. Let us see the first question in this. Question number 1 is, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients of the polynomial. Let us see the first part of it. First question is given, your quadratic polynomial is x square minus 2x plus minus 2x minus 8, x square minus 2x minus 8, and you know that your standard form of quadratic polynomial is ax square plus bx plus c. So let us compare this quadratic polynomial with ax square plus bx plus c. You will get the value of a, b and c separate. So a is the coefficient of x square, which is 1, b is the coefficient of x, which is minus 2, so c is equals to the constant term, which is minus 8. So we got the value of a, b and c. Afterwards, let us factorize to find out the zeros of this quadratic polynomial. So this x square minus 2x minus 8, by splitting middle term, we have written this minus 2x in these two parts, x square minus 4x plus 2x. So minus 4x plus 2x, you will get minus 2x and minus 8. You know the method of splitting this middle term. So 8 is factorized into two parts, 4 2 is 8, so minus 4 plus 2 is minus 2, we have taken it. Okay. Now this x square minus 4x plus 2x minus 8, make the pair of this is, so you will get two pair. First pair is x square minus 4x and second pair is 2x minus 8. From the first pair you have to take x as a common. You will get in the bracket x minus 4, and from second pair 2 as a common, x minus 4. So the both of the factor you will get x minus 4 and x plus 2. These two factors gives you the two zeros of this quadratic polynomial. So let us see how these zeros you can get. Take this factors is equals to 0. So x minus 4 multiplied by x plus 2 equals to 0. It means the product of these two numbers is equals to 0. Therefore it shows that either both of the numbers are 0 or one of them are 0. So here we are going to take both are equals to 0. First, x minus 4 equals to 0. When you take x minus 4 equals to 0, you will get x is equals to 4. So it means this is the first zero of this polynomial. Let us suppose that this is alpha equals to 4. Any problem, students? So first factor you got, first zero you got 4. Let us see the second factor equals to 0, x plus 2 equals to 0. So when you take x plus 2 is equals to 0, you will get x is equals to minus 2. It means this is second 0, beta is equals to minus 2. Now it is time to verify the relationship between zeros and the coefficients. So as you know that alpha plus beta, it means sum of zeros is equals to minus b upon a. This is zeros and this is the coefficients. So you will get minus of the value of b was minus 2 upon a is equals to 1. So minus of minus is plus 2 upon 1 is equals to 2. So alpha plus beta you got 2 with the help of its coefficients. Now find the values of this alpha and beta. Alpha was 4, alpha plus beta. So 4 plus and beta is minus 2. So 4 minus 2 is equals to 2. It means in both the cases the value of alpha plus beta is equals to 2. It is verified. So one more formula you have, that is product of zeros, which is alpha into beta. Let us verify that one also. So alpha into beta is equals to c upon a, which is minus 8 upon 1, and minus 8 upon 1 is equals to minus 8. Now find alpha into beta with the values of alpha and beta. So alpha into beta equals to 4 into minus 2. So 4 2s are 8 and plus into minus is minus, which is equals to minus 8. It means in both the condition the value of alpha into beta is minus 8. It is verified. Okay, let us see the another example. Example number 3rd. In this, the question is given your quadratic polynomial is 6x square minus 3 minus 7x. Is this in the standard form? No, it is not in the standard form, because this is minus 3, it is constant term and written in the middle. So we have to make this polynomial in standard form, which is equals to 6x square minus 7x minus 3. Now compare this equation by the standard form, which is ax square plus bx plus c. So when you will compare, you will get a is equals to 6, b is equals to minus 7 and c is equals to minus 3. A is the coefficient of x square, b is the coefficient of x, and c is the constant term. After getting these values of a, b and c, we have to factorize first of all. As in the factorization, 6 into 3, 6 3s are 18, and with the help of this 18 we have to bring minus 7. So 18 can be written as 9 2s are 18 and 9 minus 2 is 7. So here we have to bring minus 7, that is the middle term. So this minus 7x is split into two parts, minus 9x plus 2x. So after getting these four terms, we have to make two pairs from this. From the first pair, let us take the common. So 3x is common from first pair. You will get 2x, 3 2s are 6, 2x minus 3 3s are 9. And from the second pair, 1 is common. So 1 taken common, 2x minus 3. So you factor, you got 2x minus 3 and 3x plus 1. Now with the help of this factor, you will get both of the zeros from this is. So alpha is equals to, which is 3 upon 2 minus plus, it will be 3 upon 2, and second beta is equals to minus 1 upon 3. Now you got the value of alpha and beta also, and the coefficients a equals to 6, b is equals to minus 7 and c is equals to minus 3. Let us verify. Okay, in the verification, as you got alpha is equals to 3 by 2 and beta is equals to minus 1 upon 3. So as you know this formula, sum of zeros means alpha plus beta equals to minus b upon a. You just substitute the value of b and a, you will get minus of minus is plus, 7 upon a is equals to 6. So 7 upon 6 is the value of, with the coefficients you got. Now with the help of this particular values of alpha and beta, 3 by 2 plus and beta is minus 1 upon 3, you will get 9 minus 2 upon 6, which is equals to 7 upon 6. So it is verified here. Alpha plus beta means sum of zeros. We have to multiply the product of zeros also. And you know that the formula of product of zeros, alpha into beta equals to c upon a. C, the value of C is minus 3, A is 6. When you simplify it, 3 ones are 3, 3 twos are 6, you will get minus 1 upon 2. Now you have to find this alpha into beta, means product of zeros, with the help of values of alpha and beta. Alpha into beta equals to 3 by 2 into minus 1 upon 3. This 3 is cancelled. As this 3 is cancelled, you will get the value of this is minus 1 upon 2. In both the cases the value is same, so it is verified. Okay, let us take the other example which we have taken, the fifth part of this question. In the fifth part of the polynomial is given t square minus 15. Compare this t square minus 15 with the standard form of quadratic polynomial, ax square plus bx plus c. Here variable is t, so at square plus bt plus c. You will get the value of a, b and c. A is equals to 1, which is coefficient of t square. B is equals to 0 because there is no t term, and the constant term is minus 15. Okay, now factorize it. T square and this 15 can be written as square root 15 whole square. So now you, with the help of the formula a square minus b square, you can write it a plus b into a minus b, means t plus root 15 into t minus root 15. So you got the two factor of it. With the help of these two factors, you will get the value of both the zeros alpha and beta from this formula you have taken in this. A square minus b square equals to a plus b into a minus b. Okay, therefore the first zero alpha is equals to minus root 15 under root 15, and second zero beta equals to plus root 15. Okay, as you got the values of alpha and beta, so let us verify this question. Alpha plus beta equals to minus b upon a, so the value of b is 0, so 0 upon a is 1, you got 0. Now from this, the values of alpha and beta, alpha is minus 15 and beta is plus 15. Minus 15 plus under root 15 equals to 0. So here the values of alpha and beta are, in both the condition is 0, so it is verified. Now you have to verify the product of zeros also. From the product of zeros, minus 15 alpha into beta is c by a, minus 15 upon 1, which is minus 15. Now minus root 15 into plus root 15 alpha into beta is equals to minus under root 15 into under root 15 is 15. So in both the condition, both the values are same, therefore it is also verified. Understood, students? So take the videos very carefully and get the concept of the questions. How's the verified this zeros of the polynomial with the coefficients. Okay, let us see the second sum of this exercise. Find a quadratic polynomial each with the given number as the sum and the product of its zeros respectively. Means sum of zeros, it means alpha plus beta, and product of zeros, it means alpha into beta will be given here in this question. So let us take the first part of it. Given 1 upon 4 means it is sum of zeros, that is alpha plus beta, and minus 1, which is the product of zeros, it means alpha into beta. So alpha plus beta is equals to 1 upon 4 and alpha into beta equals to minus 1. These two things are given. Okay, now we have to find out the quadratic polynomial. So this quadratic polynomial we can get by two ways. So both the method I am going to explain here. See it clearly, understand the method which is easy for you, that you have to take it. and according to the condition you have to apply it. Okay, let us see the first method. As you know that a quadratic polynomial in terms of the sum of zeros and the product of zeros are as follows. So your polynomial px equals to k constant multiplied by x square minus alpha plus beta into x plus alpha into beta. This we have discussed in the previous videos, that you have to see it clearly. So this is used as a formula. So here alpha plus beta, and you have the value of alpha plus beta, which is 1 upon 4. So you can substitute here in this formula directly. You will get your polynomial alpha into beta, which is minus 1. So substitute it. K into x square minus alpha plus beta equals to 1 upon 4 substituted, and alpha into beta equals to minus 1. Now take 4 as LCM. For LCM we have taken, so 4 k upon 4, 4x square minus 1x and minus 4, you got your required polynomial. Now k upon 4 you can take the another constant k dash equals to k upon 4. If you substitute it, you will get your quadratic polynomial 4x square minus x minus 4, which is your answer. Now see the second method. From the second method we have to get the value of a, b and c separate. After getting the values of a, b and c, then we have to substitute this in the quadratic polynomial. You will get your answer. So as you know, alpha plus beta equals to 1 upon 4. It means this is minus b upon a equals to 1 upon 4. So this 1 you can write at the place of a, and this a you can write at the place of 1. So you will get minus b upon a equals to a upon 4, and we had taken it k equals. So minus b upon 1 equals to a upon 4 equals to k we have supposed. Now b is equals to minus k and a is equals to 4k with this equation. Again you just take the product of zeros, means alpha into beta is equals to minus 1, and this alpha into beta equals to c by a. Now substitute the value of a here. A is equals to 4k. You will get c is equals to minus 4k. Now you got the values of a, b and c. After getting the values of a, b and c, substitute these values of a, b and c in the standard form of quadratic polynomial, which is p of x equals to ax square plus bx plus c. Now the value of a is 4x, 4k into x square, value of b is minus k plus bx and plus c. C is equals to minus 4k. After substituting, you will get this polynomial 4kx square minus plus into minus is minus kx and plus into minus is minus 4k. Now take k as common from these all term. So k, after taking the common, you will get 4x square minus x minus 4, which was the answer in the first method also. Okay students, so after solving these questions, you are able to solve all the sums of exercise 2.2. Solve these questions of exercise 2.2. If any queries, you just forward it. We will give you the solution. Best of luck. Thank you.